In this example problem, we want to know at what rate, so power, that energy is transferred through a glass window pane that has a cross-sectional area of 0.25 meters squared and a thickness of 5 millimeters. And we want to know what this power rate would be when the temperature inside is 20 degrees C and the outside is 5 degrees C. Alright, so we're dealing with conduction here, so we're going to use our conduction equation. So the first thing I need to do is note that we're looking at glass, so we're transferring energy through glass, which has a thermal conductivity of 0.8 joules per second meters degrees Celsius. Now notice I've erased here. Each textbook or each resource might have slightly different constant values, so I had to erase and change it when we switched textbooks. So if you're looking things up on the internet, you might find slight variations in constants. I then multiply by the area. I've given it to you in meters squared, so you can just plug that number in. Both the temperatures are in the same units, so remember temperature hot minus temperature cold. And then we need to divide by the length that the energy is transferred through, or the thickness of the glass. And remember, I need to convert this from millimeters into meters, so I'm going to multiply by 10 to the minus 3, which is the same thing as dividing by 1,000. I then get a power of 630 watts. Now what's interesting to note, and you actually do this in one of your review problems for this particular exam, is compare what this rate is for glass compared to air of the same shape. The thermal conductivity of air is actually lower than for glass, which is why you use double paned windows, because the air does not allow for the transfer of energy in between the two window panes as well. And in fact, they tend to even use something like a noble gas, which has an even lower thermal conductivity, to try to prevent that transfer of energy during the winter from outside to inside and during the summer from outside to inside.